Hello guys, my name is Raghavendra. So now I'm going to explain you about full adder in deploying on the FPG Zynq SoC FPG board. Here you seen this FOC board. Here I'm using full adder this board. It is a Zynq board. Uh, Here we seen that four input ports and two LEDs as I used that three inputs A and B and C and three and LED for sum. Here I use for the sum and C out for that full adder. Basically I used that. So now I'm going to explain about the code and constraint file. uh, Code I simply write it that logic has input and outputs as we know that basic model has inputs and outputs and has seen that logic I use it for assign and calling for the uh, some logic A into B into C into for that sum for C out for that logic has A into B, B into C in, and those are the carry C out. Now I'm going to show you about constraint file. Uh, as I what is constraint file? Is a constraint file is a hardware that as this board as showing as this board has a hardware to show that. What is the ports and how to define that port, what will call and to communicating the proper way that to hardware for that use that port actually. Or I am using for constant file as I say that inputs switches inputs A, B and C in and for LEDs I use it for that sum and C out as I shown that LEDs are the two LEDs I use that as partially I show that here as showing that already synthesized and implemented status as completed so I does not wanted to synthesize and implemented and if you want to do synthesis and implementation you go for here and you run the synthesis and next you go for implementation for implementation you go from here and implement the whatever the code whatever the code next implementing what we'll do for that we'll do for the generating a bit stream why we want to generate a bit stream for that you have to flash the hardware so that you have to generate a bit stream after that I'll show you here the post synthesis and post implementation graph how that I show in tabular form uh, here the utilization available utilization percentage here showing that as a code I open input pins and RAM get the power how the chip total power consumption of the chip on chip and summary is the here as you seen that we'll go for the reports. I'll explain briefly explain about the reports. And by the way I will showing as a design runs has show the status of the have you completed here you see that tick mark has synthesis has completed and implementation has completed and what is the status synthesis diagram has completed the final position synthesis diagram as the final position of the synthesis as completed is showing that next writing bitstream completed I already generated bitstream so that you show that I already completed bitstream next I want to go for the reports as here reports for that power reports input I hope the reports utilization reports control sets reports here you see that reports root status report. You'll see simple that root status report. Open the report. Here we see that reports. Total number of next number of need here the information about that routine status, put your code of that. Clock utilization, clock utilization, how much clock utilization can takes our code as full adder. We does not need clock. I does not we does not need clock. So I didn't consider this one. So that next I go from the uh, diagram here elaborating. If you want to see that systematical how your code will be this code converted to systematical diagram. To that you have to do that RTL analysis. For RTL analysis, you have to run before that. I already completed as showing as a project summary. Already completed that. For that, so I'm going for the uh, systematical. For the systematical, it's going for the reading the nest files and internally. So I put in the background. Okay, why it's coming? Elaborating diagram. Yeah. So for that, I will explain you remaining part. Will you see that message part as explain about in message part as explain about the status of the code and what is it is about log files. Like it briefly explain what happening if you want to get errors. Here we see that. So finally we get synthesis. So as I say that three inputs A and B and C for full adder and C out and some two outputs as A and B and C three are the switches as I shown that here diagram. Hmm. Here three switches I use it for that and I already previously explained that I recalling that here two are the sum and carry. I just recalling that for understanding. After analysis this thing, you have to dump the code and the hardware part. So you go for flow and then open the hardware manager. Then tap open the target if open the target and finish done and if the code board will detected then you flash the program show the bitstream file and you flash it after flashing I will show the output how I'll get
as in showing that when we do two inputs, one input it gives some only. When we give two inputs, whatever inputs I like showing that need two three A and B two inputs, let it comes carry, and whatever I give three inputs it's showing that sum and carry. Like this the implementation I done as a FPGA book. So thank you for watching.